Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, we're going to throw the lines open because this hour is your hour. Okay, well, let's move on now and take the first listener phone call.
Hi, my name is Scott Kitchen. I'm from Roncevert, West Virginia. I'm listening to like 97.3 out of White Sulphur Springs. And I would like to say that I think that they never talk about the Earth, actually maybe having a comet hit the Earth and bringing the actual DNA that has made up our Earth for many years. And I was thinking maybe at first, the first one that hit was dinosaurs, and then the next one that hit had the other things, I mean, I think that maybe we are an experiment from another galaxy that might have sent it our way for just like a way of transporting DNA from one solar system to another. Thank you.
Well, you raise an interesting possibility. First of all, it's not the dominant thinking within scientists, but there are some scientists who advocate exactly what you're pointing out. First of all, most scientists would say that life started perhaps on the planet Earth, perhaps in the oceans, perhaps near a volcano vent. You have heat vents on the bottom of the ocean, which are quite hot, giving us a source of energy and fuel. And that energy was then used to assemble protein molecules and eventually DNA. DNA can replicate itself. So once you have one molecule, you have two, then 4, 8, 16, 32, 64, 128, ... And pretty soon you have cells of DNA which reproduce themselves at the bottom of the ocean. And then later, these cells learn to create photosynthesis, and then they begin to populate the oceans. Now, that's normally how it's taught in textbooks. However, there are some renegade scientists who say, nope, perhaps it came from outer space. And the reason why they say this is very simple. The Earth was created about 4.5 billion years ago. Life goes back about 3.5, 3.7 billion years ago. But for the first billion years or so, the Earth was quite hot. There were meteors and comets landing into the oceans, evaporating them. And so there was only a small window of opportunity between when the bombardment by meteors stopped and the oceans became stable and life began. And some people say that window is so narrow, just a few 100 million years, that it could not have been an accident. It would take billions of years, they say, to create DNA from nothing, and yet DNA got off the ground within a few 100 million years. Aha! They say life came from outer space. Now, the most vocal person who believed in that was a cosmologist, Fred Hoyle. He was perhaps the most famous cosmologist of his time, but he never won the Nobel Prize. He never won the Nobel Prize, some people think, because he had, strange ideas, like the fact that perhaps life came from outer space rather than coming indigenously from the planet Earth. And he was also offended by the fact that a woman scientist was denied the Nobel Prize for the discovery of the pulsar, and he wrote about it. Jocelyn Bell, who discovered the pulsar, did not win the Nobel Prize for this discovery. Her thesis advisor won the Nobel Prize, and Fred Hoyle got very angry about this, wrote about it, and some people think that the Nobel Prize Committee deliberately did not give the Nobel Prize to Fred Hoyle because he had these strange ideas about Genesis from outer space, and also about the fact that sexism was perhaps pervasive within the Nobel Prize Committee. Well, we don't know for sure. No one was there to witness the event. We're not sure, but again, the dominant theory is that life started on the planet Earth, but you cannot rule out the fact that life may have started from outer space. Another reason for believing that it's possible that life came from outer space is the fact that meteors from Mars have landed on the Earth. That's right. You don't have to go to Mars to do it. Meteors from Mars have landed on the planet Earth. Now, how do we know that? By analyzing meteors, we find that some of them have exactly the signature of Martian rock. Well, let's take a short commercial break. And after the break, we're going to talk about, well, did life come from outer space, and are you really a Martian? Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Well, before the break, we had a very interesting question from somebody who thought that, well, maybe life came from outer space. Well, there are pros and cons to that idea. The dominant theory is still that life started on the planet Earth, perhaps in the oceans, but you can't rule out the fact that DNA may have come from outer space. Now, why do we believe that? First of all, meteors from Mars have been found on the planet Earth. How do we know they're from Mars? Because when we look at the mineral content and the air content within the meteor, we find, bingo, a precise match with the chemical composition of Mars and the composition of the atmosphere of Mars. So this forced us to rewrite the astronomy textbooks. We now realize that meteors have slammed into Mars and shot debris into outer space, some of which then eventually landed on the planet Earth. Now, Mars cooled off before the Earth 4 billion years ago. Some people think that Mars was tropical when the Earth was molten. Therefore, perhaps life started on Mars first, and then perhaps a meteor slammed into Mars, and then brought Martian rock to the Earth with, who knows, DNA on it. If this theory is correct, it means that if you want to see a Martian, simply look in a mirror. Now, of course, we don't know whether that theory is true or not, but you can't rule it out. Meaning that, yes, it's possible that DNA could have come from outer space. It can't be ruled out, even though it's not the dominant theory. Okay, let's move on now to the next listener phone call.
Stu, Muldoon, Alaska. And my question is it possible to damage your eyes by looking into space on an average night? I had a relative who had macular degeneration, and she claimed that she actually felt her eyes get injured while stargazing once. Is there something that people have to be aware of? Is there a relationship? Thank you.
Well, off the hand, I would say no. You can't rule things out of the question, but normally macular degeneration occurs with time. That is, as people age, you get degeneration within organs of the human eye. And cataracts, for example, can be accelerated by ultraviolet radiation, by getting too many suntans. And so macular degeneration is a problem, but starlight, you can actually measure the amount of radiation coming in from starlight, and it is very small. Your eyes have to dilate in order to collect enough starlight to make an impression. So, of course, it's always good to talk to an ophthalmologist or an optometrist about this. But at first guess, I would tend to doubt that starlight alone would be responsible for macular degeneration, given the fact that it's one of the symptoms of the aging process. Okay, well, let's move on to the next listener phone call.
Yes, my name is Andrew Phoenix. I'd like to ask a question concerning 2012, the movie. Is it realistically a way to leave this planet or protect yourself if it ever happens? Thank you. I love your show.
Well, 2012, as I recall, was a movie about doomsday. And if doomsday were to happen, then, of course, all hell's going to break loose, and people want to know, how can I get out of here? And so then we're left with possibilities of, well, what options do we have if doomsday comes? Well, it all depends on the type of doomsday you're talking about. For example, Given 10,000 years, we expect there to be another ice age. 10,000 years ago, we had an ice age, and ice ages are more or less periodic, and so we expect another glaciation period to commence about 10,000 years from now. And then what are we going to do? Back then, North America was covered in about a half a mile of ice. Cities will be covered in solid ice. And at that point, some people think, well, 10,000 years from now, we'll have enough technology to leave the planet Earth or go underground and perhaps create heating units which will keep us warm and cozy underground. So that's one possibility. Another possibility is to go into outer space and orbit the planet Earth. But of course, these ice ages go on for thousands of years. And who wants to live in a space station for thousands of years? And so there are some people who say that either we should go underground and have artificial heat underground to keep us nice and warm and cozy, or we should go into outer space. Another possibility, of course, is if a doomsday rock were to come and hit the Earth, it wouldn't take much to destroy life on the Earth. An object just 6 miles across or so slammed into the Yucatan of Mexico 65 million years ago and pretty much wiped out the dinosaurs. Now, some people then believe that if we are hit by a rock from outer space, we should go into outer space and perhaps go to places like Mars. Now, of course, we're not talking about moving the entire population of the planet Earth to Mars. That would be too much. However, Elon Musk has stated that he foresees a time when 1 million people could live on the red planet. And he even worked out the mathematics. For example, he has a huge rocket on the drawing board. It's called the BFR rocket. B for big, R for rocket, and F for your imagination. Well, the BFR would be big enough, he says, to shoot maybe several hundred, maybe 1,000 colonists to the red planet. And if you have enough of these missions, perhaps you can eventually get a colony of 1 million people on the red planet, which would be self-sustaining. And then we have Jeff Bezos, richest man on the earth, founder of Amazon.com. Jeff Bezos even has a spaceport in Texas, where he hopes to launch rockets which will eventually create a habitat for humans in outer space. He also thinks that perhaps 1 million people will eventually live in outer space and work in outer space. And his long-term goal is to make the Earth into a garden. So the Earth becomes a garden, and all the heavy industry is moved into outer space. So all the pollution and all the nastiness and toxic chemicals gets moved into outer space, and the Earth itself becomes a park or a gigantic garden. And then you have some people who believe that perhaps we should go to the stars. Now, in my book, The Future of Humanity, I give you the details of what it would take to build a starship. Now, of course, no one is saying that we're going to build a starship anytime soon. Stephen Hawking, my colleague, believed that we should send postage stamp starships to the nearby stars, and that could be done within a matter of decades. But it may take centuries to create a starship that you would see on Star Trek. A Star Trek containing hundreds of people capable of creating a mission to create a colony in a distant star system. So again, there's no law of physics saying that we can't do it. It's just that it may take a few centuries before we have that capability of reaching for the stars. Okay, let's move on now to the next listener phone call.
Hello, Professor. This is Scott in Bertram, Minnesota. I'm wondering why we don't harvest the great pressures at the bottom of our ocean. It would be like harvesting gravity. Is there an energy exchange problem there, getting those pressures to the surface? Just wondering if you have any ideas. Thank you.
Well, many people have thought about mining the ocean somehow, but there are practical problems. The Navy, for example, Oh, by the way, let's take a short commercial break, and after the break, we'll talk about mining the oceans for heat and for energy. Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a call coming in about the oceans. Is it possible somehow to harvest the energy or the pressures in the oceans? Well, yes and no. First of all, the Navy, the U.S. Navy, once had an idea to create a perpetual motion machine out of the oceans. First of all, there is a temperature difference as you go down into the ocean depths. It gets colder down there. And whenever you have a temperature difference, you can extract energy from that temperature difference and create mechanical motion. You get this from what is called the second law of thermodynamics. Every time you have a difference in temperature from T1 to T2, you can extract mechanical energy from that difference. That's how motors work, and that's how refrigerators and many of our appliances work using the second law of thermodynamics. So here's what the Navy thought about. Let's say I have a tube that goes into the ocean. It's cold on the bottom, warm on the top, which means that water then circulates in the tube, and you have a temperature difference. And whenever you have a temperature difference, you can extract mechanical energy from that to propel your engines, and thereby you would have a perpetual motion machine. Well, on paper it sounds great, but in practice they're not very efficient. And they're quite awkward to have this very long tube going from the ocean depths to the top of the oceans. So the Navy never really took this idea that seriously. Also, you have another problem, and that is even if you have water under tremendous pressures at the bottom of the ocean, as soon as you bring it up to the surface, the pressure goes to normal. And so you lose whatever pressure you have. And so trying to use pressure alone to create energy from the oceans, well, it doesn't work. But again, people have tried to extract energy from the oceans, but so far no one has found a reliable way of doing it better than an ordinary oil-fired engine. Okay, let's move on to the next listener phone call.
Okay, my name is Glenn Thomas. I'm calling from Oysterville, Washington. Question I have. Some years ago I heard about something called conservation of information. It was bandied about as being something coming out of quantum mechanics, and it was used in the context of what happens to whatever information was contained in something falling into a black hole. My question is, I'm not sure what is meant by information that's being conserved. When physicists talk about conservation of information, exactly what is it they're talking about conserving?
Okay, well, you asked a question that was the center of a heated debate between Stephen Hawking and rival physicists, and we'll talk about that after the break. So after the break, we'll talk about black holes, what happens if you fall into a black hole, and is information lost permanently when you fall into a black hole? Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. That's right, it's open mic on Science Fantastic. Well, before the break, we had a question about a controversy which is still ongoing among physicists. And that is, what happens if you throw the encyclopedia into a black hole? Is the information in that encyclopedia lost forever? Or is it somehow preserved? Well, Stephen Hawking, the late cosmologist, said that information is lost permanently. Sorry about that. You throw the encyclopedia into a black hole, and it never comes out. It's lost forever. However, other physicists, myself included, believe in what is called a quantum theory, and that theory comes out of atomic physics. And in atomic physics, information is never lost. So even if you have the Encyclopedia Britannica and you burn it, the information is still encoded in the ashes. So that if you could recreate molecule for molecule, somehow recreate molecule for molecule the burning of the Encyclopedia Britannica, you could recreate the encyclopedia from ash. Sounds incredible, but that's the way physics goes. And that's called quantum mechanics. It works at the atomic level, and we are made out of atoms, so in principle, you can retrieve the information of a burnt encyclopedia. But Stephen Hawking said that fails for black holes. Well, that earned the ire of many quantum physicists who said, nope, quantum mechanics must prevail, so information is hidden someplace when you throw the encyclopedia into a black hole. Well, Stephen Hawking finally admitted he was wrong. Quantum mechanics, the highest version of quantum mechanics, is called string theory, which is what I do for a living. And in string theory, information is never lost, even in a black hole. So, where did the information go once you throw the encyclopedia into a black hole? Well, it turns out that black holes are not really black. They're gray. In fact, that was Stephen Hawking's big contribution to physics, that he showed that because of quantum mechanics, you cannot have a perfectly black hole that eats up everything. Something's got to be left over that oozes out slowly, called Hawking radiation. So Hawking radiation is a byproduct of quantum mechanics. So the next step would be that somehow the encyclopedia is encoded in the Hawking radiation. And Hawking finally admitted that, well, he was wrong. It turns out that, most physicists believe this, that as Hawking radiation slowly oozes out from a black hole, so the black hole becomes gray, not black, the information of the encyclopedia is encoded in slight irregularities in this radiation. So it's ironic. It's ironic that Hawking radiation was used to disprove Hawking. So we do believe in Hawking radiation, that's the quantum effect, but we also believe that information is never lost, because that's also a quantum effect, and Hawking, to his credit, said he was wrong. Quantum mechanics wins, and as I mentioned, the highest version of quantum mechanics is string theory, and that's what I do for a living. In fact, I'm the co-founder of string field theory, which is one of the main branches of string theory. Okay, well, let's move on now to the next listener phone call.
Hi, this is Brenda from WSPA in Fort Payne, Alabama. When I suddenly think of someone that I haven't seen in years, are they also thinking of me at the same time? Thank you.
Well, you ask a very interesting question about synchronicity. I've had that experience when you think of somebody and then the phone rings and there they are. Or you think of somebody and you say, I'm thinking about somebody today. And then you meet them later and they say, well, gee, I was thinking about you too at the same time. And then you realize, gee, that's strange. What is the probability? What's the probability that I'm thinking about somebody and the phone rings right at that moment? Or the probability that somebody will be thinking about me when I'm thinking about them? Well, we'll try to answer that question after the break.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Well, before the break, we had a call about something that I think all of us have experienced in some form or other in the past, and that's called synchronicity. And that is, you're thinking about somebody, the phone rings, and bingo, there they are. Now, what's the probability? What's the probability that of all the people you're thinking about, of all the times for a phone ring, and there it is? It's magic. And then you say to yourself, I'm psychic. I'm psychic. Or you're thinking about somebody and somebody else you meet later says, yeah, I was thinking about you at the same time you were thinking about me. What's the probability? Well, it turns out the scientists have actually studied this effect because it has to deal with our memory. It turns out that we, as human beings, forget most of what comes at us because it's irrelevant, not important. Otherwise, our brains will be cluttered with billions and billions of irrelevant things that mean nothing to us. So, when the phone rings and it's somebody that we're not thinking about, we forget about it. It doesn't affect us because it's one more piece of extraneous information that we don't need to clutter ourselves with. But when somebody calls us that we were thinking about, bingo, we say to ourselves, magic. I'm psychic. I'm psychic. I was thinking about that person and he calls. What's the probability of that happening? Well, it turns out that the brain remembers the hits and forgets the misses. Now, next time you see a psychic on television, mind reading, or a psychic that is talking to dead people, watch how they do it. They ask lots of questions, they get lots of misses, but you forget the misses. That's the nature of memory. Memory forgets the unimportant misses, but only remembers the hits. So as soon as a hit is made, you say, the guy's a mind reader. He's psychic. He's talking to dead people. That's how you do it. Because memory has to be very conservative, so it throws away most of what is unnecessary and only remembers the hits and forgets the misses. And that's how psychics work. Next time you see a psychic reading, notice that most of the questions yield mistakes, and the ones that yield hits, those are the ones you remember. That's the nature of memory. Okay, well, let's move on to the next listener phone call.
Hello, Dr. Kaku. Albert here in San Jose, California. I love your show on YouTube. That's where I catch it. Say, listen, I wanted to ask you, mysterious photos of Mars would seem to be artifacts of artificially made things that have been spotted here and there, or like this crab recessed in a rock. Why in the heck can't they turn that rover around and go back to it and do an inspection on these mysterious artifacts? You know, that's one thing I'm not too clear about. Why don't they go investigate these things? Thanks, and I love your show. Thanks so much, Dr. Kaku. Have a good one. Bye-bye.
Well, thank you. And let's talk a little bit about Mars, because on Science Fantastic, we've had the people on the Mars rover expeditions on the radio show talking about these things. And I asked them that very same question. I said, look, you make a living looking at Mars, looking at the photographs of the Mars rovers. Some people claim that there are even rock formations that look artificial. And so why don't you investigate these things and have a press conference and announce these things? And they tell me an answer which is quite unusual. Their answer is they would love to do it. They would love to do it because they would be famous. They would get grant money. Their names would be in newspapers across the country, and they could get as much grant money as they want if they find a formation on Mars that is obviously created by an intelligence. They'd love it. But they say, no matter how hard they try, they have not found anything that looks like it was created by a life form. Sorry about that. Now, there is something about the human brain's understanding of memory and what it looks at. It turns out that our ancestors were quite timid. Every time they thought they saw something in the forest, like rustling leaves, the alarm bells went off, and the brain says, there's a tiger. There's a lion hiding in the bushes, when actually there's nothing at all. This means that we see things that are not there because it's good for us. It was good for our evolution. When you look at the sky, look at the clouds, you can't help it but see strange objects in the clouds. You see Disney characters. You see animals. You see all sorts of things in the clouds. You can't help it. Your brain forces upon you the fact that it sees familiar objects in clouds, even though, of course, there's nobody up there. Now, why is that? Because for the most part, when you see rustling of the leaves in the forest, there's nothing there. It's just the wind. Your brain says maybe it's a tiger, maybe it's a lion, but there's nothing there. Now, why does your brain do that? Why does your brain fool you? Because 9 times out of 10, there's nothing there. But 1 time out of 10, there is a tiger. There is a lion, and it saves your butt. It saves your life. You run like crazy. So, in other words, our ancestors were timid. They were timid, and that's why they had children who eventually became us. However, our ancestors that were not timid, they didn't have this ability, and the rustling of the leaves meant just rustling of the leaves. 1 time out of 10, they got eaten up by a tiger. So in other words, it's good for us to see things that are not there, including photos of things on Mars. Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, well, this hour is your hour. So let's move on now to the first listener phone call.
Hi, Michio Kaku. I just want to say you're the most amazing person that I listen to as far as YouTube videos go, and I like the way you make my brain think. I just had a quick question. Being since time travel is possible, do you think we have been visited from people or agencies from the future?
Well, you asked a question that we physicists have actually debated. It was first asked by Stephen Hawking, the late physicist, who said that, well, time travel may not be possible because where are the tourists from the future? They should be traveling into the past to visit us, and where are they? We don't see them. Therefore, maybe time travel is not possible. But I thought, now, wait a minute. You can't jump to conclusions like that, because let's say we can go back to the dinosaur era. After you see one dinosaur have lunch, you get bored. I mean, who wants to see 2 dinosaurs have lunch when you've already seen one? And as a consequence, you lose interest. So maybe there are time travelers from the future, but they just got bored with us. They simply realize that we're not that interesting, especially if you see the same thing over and over and over again. So that's one possibility. There's another possibility. We will have invisibility long before we have the first time machine. In fact, the United States Pentagon is working on invisibility. So once we attain invisibility, maybe we will visit the past, but we'll just keep ourselves invisible and people will not see us. Well, I have my own attitude toward this. First of all, time travel may indeed be possible. Einstein's equations allow for time travel. Einstein's equations allow for wormholes. Some of these wormholes can go to the past, in which case you may be able to meet your teenage mother before you're born and create mischief before you're born. And then how can you be born if you just prevented your parents from mating? Well, it turns out that there is a way out of all these paradoxes. There are a lot of paradoxes you can make in time machines. For example, let's say you go backwards in time and shoot yourself as a child. If you've committed suicide as a child, then how can you grow up to be an adult? So how do we answer these things? Well, the way we answer it is as follows. In quantum mechanics, you have something called the many worlds theory, where the universe splits in half. In one half, for example, a cat could be dead. In another universe, a cat could be alive. The universe simply splits into 2 timelines. If that's possible, then when you go backwards in time, the universe splits. So let's say you want to save Abraham Lincoln from being assassinated at the Ford Theater. When you go backwards in time and you meet John Wilkes Booth, You do prevent John Wilkes Booth from killing Abraham Lincoln, but the universe splits at that point, and you've saved somebody else's Abraham Lincoln. Your Abraham Lincoln died. But in this other universe, which budded off our universe, that universe, Abraham Lincoln survived. So that's how you answer all the paradoxes of time travel, that the timeline simply splits. So, is it possible to go backwards in time and meet us in the past from the future? And the answer is yes. But how come you have no memory of it? Because the timeline split in half. Therefore, in one timeline, you do have memories of it, but the other timeline, you do not. And so all the paradoxes of time travel can, in fact, be solved once you allow the timeline to split in half. Now, let me now give you the mother of all time travel stories, and you can see how to resolve this time travel paradox. This paradox was created by Robert Heinlein. It is the mother of all paradoxes, and see whether or not you're smart enough to figure it out. First of all, the year is 1945. A stranger comes in from the forest carrying a baby girl in a basket, and he leaves the baby girl at an orphanage. The nuns at the orphanage don't know what to do with this baby girl, abandoned at the doorstep, so they call her Jane, and Jane grows up wondering, who's my mother, my father? Well, one day, a handsome stranger comes into her life, and Jane falls in love. But it was not meant to be. They quarrel, and the handsome stranger stomps off into the forest, never to be seen again. But Jane is left pregnant and abandoned. It's a very sad story. So she gives birth to a baby girl, but somebody that night kidnaps her baby girl, and the baby girl is lost forever. Well, it's even worse than this. It's a very sad story. Jane finds out that she is hermaphroditic. She's half male, half female, and the doctors find out she's bleeding, and they have to change Jane into Jim. Well, Jim now wakes up really messed up, left as an orphan, grows up in an orphanage, finds a lover, left pregnant, and then the baby girl is kidnapped, leaving her as Jim. Well, Jim gets into barroom fights every time someone says, who are you? Where'd your mother come from? Where'd your father come from? Who are you anyway? Well, I'll give you the mystery of who Jane is after the break. Who is Jane if she's a time traveler? Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a question about time travel, and how do we resolve the fact that we don't see tourists from the future, or what about all those paradoxes you get if time travel is possible? Well, just before the break, I gave you the mother of all paradoxes, the greatest paradox of all time, involving time travel, cooked up by Robert Heinlein. It starts with a baby girl left off at an orphanage, abandoned. She was raised by the nuns, and they call her Jane. One day, Jane falls in love and gets pregnant, but her baby girl is kidnapped, and it's even worse than that. Jane finds out that she's hermaphroditic, she's bleeding, she's going to die. She has to be changed into Jim. Well, Jim now becomes a barroom drunk every time someone says, who are you anyway? You were left at an orphanage as a girl. You grew up as a girl, had a baby girl that was kidnapped, but now you're Jim. Who are you anyway? Well, finally, at a bar, after another fight, Jim finds in a sympathetic ear in a bartender. A bartender says to Jim, I'm really a time traveler. That's right, I'm a time traveler. Come into my machine, my time machine, and I will tell you who is Jane/Jim. They go into the time machine way into the past, and he's very disoriented. He's left in the past someplace, but then he meets this beautiful 17-year-old girl, and it's love at first sight. And, however, it's a sad story. He finds out that she's pregnant. Well, she gives birth to a baby girl, and then Jim says to himself, you know, this happened to me when I was a kid. I was abandoned. I was left pregnant. I had a baby girl, and now I have a baby girl, and I'm going to kidnap her to make sure that she has the best education possible. So Jim breaks into the hospital, steals the baby girl, and goes back into the time machine. Back until it's 1945. And then Jim drops the baby girl off at the orphanage. Well, the nuns next day pick up the baby girl, and they call her Jane. And then they wonder, who is Jane anyway? Jane, left as an orphan at the nunnery. But Jim says to himself, I got to get my act together. I can't be a drunk all my life. So he joins the Time Travelers Corps and has many exploits in the annals of time. Now Jim is an old man. He asks for one final mission, and that is to go back into the past to impersonate a certain bartender to unravel the story of who Jane is. Now, here's the question for 10 points. Who is Jane's mother, father, brother, sister, aunt, uncle, daughter, granddaughter, grandfather? Jane is a family tree unto herself. She is her own mother. She is her own father. She is her own daughter. She is her own son. All of that is possible once you have time travel. So how do we resolve this? I mean, think about it for a moment. A family get together and the whole clan gets together and one person says to the other, you did this to me. You did this to me. And the other person says, no, you did that to yourself. So the question is it possible to be a family tree unto yourself? Well, the answer is no. Because if the quantum mechanics of time travel holds, then the timeline simply splits every time Jane goes into the past. So she does not meet herself. She does not make love to herself. She does not give birth to herself because there's only one Jane. But can you imagine a food fight? A food fight breaking up at a family get-together when all the different versions of Jane get together? Well, that's the science fiction story cooked up by Robert Heinlein, where you can be your own mother and your own father. Okay, well, let's move on to the next listener phone call.
Hey, Professor Kaku. This is Jesse from Houston. And I was just wondering about your opinion on what do you think that's in the water that is on Mars, that's liquid water that's found on Mars recently. I know you've heard about it. What do you think is in that water? Do you think we're going to find some kind of life that used to live on Mars billions of years ago, way before Earth was even cool enough for us to get on it? Or do you think it's just water? Or do you, because water is essential to life, so I imagine there's some kind of like small organism, maybe a fungus, maybe some kind of something in that water. I was just wondering your opinion. Thank you, Ms. Gunther.
Yes, well, recently headlines were made when NASA scientists announced the fact that underneath the ice cover, there seems to be an ocean, a lake of liquid water. Now, why is that important? Because liquid water is the amniotic fluid of life. Liquid water dissolves most chemicals. Most organic chemicals can be dissolved in water. And that's like a mixing bowl. A mixing bowl where the first proteins and the first DNA gets off the ground. So therefore, when astronomers go into outer space looking for things, what do they look for? The water. Follow the water. That is the mantra of astronomers. And Mars seemed to have no liquid water. Mars is a frozen desert. It's frozen solid. And so the question is, can liquid water exist on Mars? Well, that's where this lake was found, which is very interesting. However, life as we know it probably cannot exist in that lake. It's probably too salty, because we expect that it is very salty to have that lake underneath the ice on Mars. However, it does mean that Mars may eventually have larger lakes, which may make it possible to have organic chemicals, which may mean that microbial life may exist on Mars. Now, this is just a theory, but let's say hypothetically that intelligent life, got off the ground on Mars billions of years ago, and then Mars gradually lost its atmosphere. If you were a Martian, where would you go, knowing that your atmosphere is going to be lost, that all the water is going to evaporate or turn to ice, where would you go? You would go A, into outer space, B, to the polar ice caps, or C, underground. And guess what? We have not gone underground, and we have not gone to the polar ice caps. That's why this discovery is very important, because there's a loophole as to where microbial life may get off the ground, a place that we haven't looked at very carefully, and that is the polar ice caps, and especially the rock under the polar ice caps. So this was quite a shock when scientists from NASA found evidence of this, and it means that Mars could be a lot stranger than we previously thought. Does it mean there's life on Mars? No, it's not conclusive. We just know that there seems to be a lake under the ice caps. However, it's probably too salty for life as we know it. For example, take a look at the Great Salt Lake in Utah. Why is it salty? Because as water begins to evaporate and shrink, it dissolves more and more salts in the ground and becomes saltier. That's why many of the lakes left over from the last ice age are quite salty, like the Great Salt Lake. So the speculation is that this lake on Mars is probably too salty to have life, but hey, we don't know. More studies have to be done. But it is tantalizing now. Perhaps Mars is a lot more interesting than we were led to believe. Okay, let's move on to the next listener phone call.
Yeah, this is David calling from Central Lake, Michigan. We all hear about these telescopes looking back into the origins of the universe, billions of years backwards. But what do these telescopes see when they look in the direction of the expansion? Can the telescope see the end of in the direction we're headed? Just wondering.
Well, you ask a very interesting question. First of all, the night sky is a time machine. When you look in the night sky, you're looking into the past, because it takes time for light to reach us. Now, when you look in a mirror, you're not really looking at yourself as you really are. You're looking at yourself about a billionth of a second ago, because that's the amount of time it takes for light to go from your face to the mirror to your eyeball. So you're looking into the past every time you see yourself in a mirror. When you look at the moon, you're looking at the moon as it was a second ago. When you look at the sun, you're looking at the sun as it was about 8 minutes ago. Well, let's take another short commercial break, and after the break, we're going to answer the question, can you see Genesis? Are our telescopes powerful enough that we can see the beginning of the universe itself as it was being created? Welcome back to Science Fantastic with Professor Michio Kaku. Give us a call and perhaps you can ask that question or make that comment about science that's always been bothering you. And before the break, we had a very interesting question. When you look at the night sky, you're looking into the past. So if you have a telescope powerful enough, could you find Genesis, the beginning of the universe? Can you photograph the beginning of the universe with a telescope? Well, the short answer is no, but let me explain why. When you look at the night sky, you're looking at the past. So when you look at the sun, you're looking as it was 8 minutes ago. When you look at Mars, or you communicate with Mars, you're looking as it was about maybe 20 minutes ago. When you look at Pluto, you're looking at Pluto as was almost a day ago. When you look at the sky and you look at the stars, the typical stars, they are usually a few hundred light years away, meaning that you're looking at light that is a few hundred years old. When you look at the distant galaxies now, like Andromeda, they are millions of light years away. So you're looking at light that is millions of years old. Fossil light. Light that has been preserved as it goes across the blackness of space for millions of years. And then the questioner asks the key question. How far back can you go? Can you go back all the way to Genesis? Well, it turns out that the Hubble Space Telescope can see, quote, the farthest star. The farthest stars that we can see with our telescope are almost 13 billion light years ago. So in other words, they go back very close to the instant of the Big Bang. But when you go beyond that to look at the Big Bang itself, what do you find? Blackness. There's only blackness there. But it's actually not blackness at all. If your eyes could see microwave radiation, you could actually see the fireball itself. That's right. You can actually see the fireball that created the universe. Go to nasa.gov, type in WMAP, and you can actually see the picture. The microwave photograph of the radiation from the Big Bang itself. This is amazing. We're talking about baby pictures of the infinite universe. Now, how old was the universe then when that light was created? 300,000 years old. So when the universe was just 300,000 years old, it created a fireball, which you can see on your internet right now by going to nasa.gov and typing in WMAP and the microwave background radiation. But our listener then asked yet another question. What happened at the instant of creation? Well, unfortunately, that photograph does not go back that far. That photograph only takes you to within about 300,000 years of the instant of creation. To go back even farther requires a new type of telescope, a gravity wave detector. And these are very expensive machines. They're several miles long. One is based near Baton Rouge, Louisiana. The other one is based in the Northwest. Gravity wave detectors, which won the Nobel Prize just recently for 3 physicists who detected radiation from colliding black holes using a gravity wave detector. Now, it turns out that to find pictures of the instant of the Big Bang requires a gravity wave detector in outer space. And we hope to launch that in the coming decades. LISA is the Laser Interferometry Space Antenna, and it is a gravity wave detector in outer space. And we hope to get baby pictures of the infinite universe as it's being born, and maybe pictures of an umbilical cord connecting the infinite universe to another parallel universe. Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. That's right, it's open mic in this hour of Science Fantastic. Okay, let's move on now to the next listener phone call.
Good evening, Dr. Kaku. This is Mike. I'm calling from Poplar, Montana. I'm actually listening to you on Paranormal Radio. And my question is, why does any number that could be a factor of 3, say like 6, 9, 12, etc., multiplied by another number that's a factor of 3, always equal, well, it could be summed up to equal 9. The answer could always be summed up by addition to equal 9, no matter the number size or the number of times you multiply other numbers that are a factor of 3. Thank you.
Well, first let me point out that's one of a series of coincidences that were discovered by the ancients. The ancients were quite good at playing with numbers. Numbers were first discovered, invented by humans to keep track of cattle, keep track of possessions. By the way, I should point out that when we were nomads, like 10,000 years ago during the Ice Age, there was no mathematics because there was no need to count anything more than 2 or 3. However, once the Ice Age ended, and then we had the ability to create cities and villages, we had wealth. Excess wealth, and we had to keep track of it. That's why we had to invent numbers, to keep track of things, because we were accumulating more and more things when the first villages were created after the Ice Age ended 10,000 years ago. Then, as cities got bigger and bigger, then we had kings and queens. They had armies to conquer other neighboring villages, and then you had to have mathematics. Not just numbers, but mathematics to keep track of all these things. And that's when the ancients noticed all these quirks about numbers. First of all, the identity that you mentioned only works in base 10. It does not work in other bases. But why 10? Because, well, We have 10 fingers, and so it was convenient to use base 10 because we count with our fingers. But not just the one you mentioned, but several of these things were noticed by the ancients. Now, proving these things then had to await the coming of algebra. With the coming of algebra, it meant that you can use symbols to represent any number with certain quantities to create an equation. And that was a tremendous breakthrough. Because before then, mathematics was just counting your possessions. That's all mathematics was needed. That's why we had accountants, to keep track of cattle, keep track of troops, keep track of things as society became more complex after the ice melted and we no longer lived like nomads chasing after the deer and the buffaloes. Then algebra was created. Now, the equations that you mentioned are actually one of a series of them involving quirks of the number 3, 9, like casting out nines. And you can prove them very simply by using algebra to use symbols to represent the numbers. So, in summary, the point I'm raising is these identities were first found by the ancients when arithmetic was discovered, but then algebra came later, and with algebra we can represent symbols to represent a class of these numbers, and thereby prove any number of these identities that even the ancients were aware of. Okay, well, let's move on to the next listener phone call.
My name is Rita. I'm calling from Kennewick, Washington. The call letters are KONA, and I'd like to ask you, we get our light from the sun, and yet between the earth and the sun is completely black. And I assume that's because there is no atmosphere. But there also is no atmosphere on Mars, and yet Mars shines with light. Don't understand that.
Okay, well, let's try to answer these things one at a time. First of all, Mars has a very thin atmosphere. And if you were to land on Mars, the sky would be pink. So we think it's pink probably because the sands of Mars are very fine powder, like talcum powder. And Mars is red because of rust. Mars is the rusty planet. And so whenever there's a sandstorm, it throws this material into the sky, giving you the reddish color. Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a question about color, about the fact that the sky is black, and yet things are not black on the Earth or on Mars. And what's the origin of the color of things? Well, let's try to answer them one at a time. First of all, the atmosphere of Mars is actually pink because of the dust that is lofted into the sky because of dust storms, and it's red because of ferric oxide. Mars is the rusty planet. Now, the sky on the Earth is blue, and why is that? Because light from the sun is scattered off the atmosphere, and blue light scatters more than red light. And that's why when you look directly at the sun at sunset, it looks reddish, because you're looking at unscattered light, and red light does not scatter much. When you look away from the sun, you're looking at scattered light, and blue scatters more than red. That's why the sky is blue. But then why is outer space black? Well, that's a question for the ages. It turns out that this is a paradox that went on for centuries. Why is the night sky black? You see, if there are infinite number of stars, which is logical, and the universe is infinitely old, then you should see an infinite amount of starlight coming into your eyeball, so your eyeball should melt. The sky should be white, not black. And everywhere you look, you should see a star, and the sky should be white, not black. Well, this is called Olber's paradox. It's one of the greatest paradoxes of all time. And the paradox was unsolved for hundreds of years until finally, of all people, Edgar Allan Poe published the first solution to Olber's paradox. The great mystery writer, Edgar Allan Poe, was also an amateur astronomer, believe it or not. And just before he died, he wrote a book where he talked about many of his dreams and things, and then he wrote down the answer to Olber's paradox. The answer to Olber's paradox is that the universe had a beginning. Therefore, when you look at the night sky, you do not see an infinite number of stars going on forever and ever. There's a cutoff. A cutoff because there was a beginning. There was a Big Bang. Now, this is deep. This is really deep. When I take a shower at night, I think about this. Why is the night sky black and not white? Because there was the Big Bang. Because the universe is not infinitely far, infinitely old. It is finite. That there was, in fact, a beginning to time, to the beginning of the universe. It's an amazing thing that I think about all the time. Now, if your eyes could see microwave radiation, you could actually then see the fireball. You can actually see the fireball that gave us the universe, the fireball of the Big Bang, if your eyes could see microwaves. Now, your eyes cannot see microwaves, but our instruments, our radio telescopes, can in fact see microwave radiation, and we can photograph the fireball. And so I think about this at night when I take a shower. Why is the sky black and not white? Because you're looking at the cutoff of light, that there was a beginning. Before that, there was no light. And that's why the night sky is black. Amazing. Okay, well, let's move on to the next listener phone call.
Yes, Doctor. I am John. And I have a question about how man fights fire. It seems that since man has discovered fire, he extinguishes it by smothering it or removing the fuel source. I'm wondering, do you see a future where man can use some type of energy, like a beam or other force that can be directed at a flame and cause it to extinguish rather than just dropping of slurry or dropping of water or throwing dirt on a fire? Is the day going to be when man can extinguish a fire through the use of counter energy rather than smothering the fire? Thank you.
Well, actually, I've thought about that question, especially in California, where you have the biggest forest fires in recorded history ravaging California, where I was born years ago. And so you begin to wonder about that question. Is it possible to create an energy source that could suck up the energy rather than simply dumping water or chemicals on a flame? Well, some people have talked about black light. That black light would be light that absorbs light, so it would be black rather than white. And if you shine black light at a flame, it would suck the energy right out of a flame. Well, that's science fiction, and so far we see no evidence of black light. And the energy that we see around us is positive energy. Using the quantum theory, we can catalog all the different kinds of energy that we see around us, and black light is unfortunately not one of these energies. However, it is a tantalizing idea that maybe one day somebody could find a way to suck up energy rather than create energy. Now, one of the problems is the second law of thermodynamics. The second law of thermodynamics has many different forms, but one of them is that flames and heat tend toward chaos, and that's one reason why fires grow rather than fires getting smaller and smaller. And so you bump up against the laws of thermodynamics. So, well, I'm not saying you can't do it, but I know of no way to create black light. I know of no way to create a way to suck up energy, because it takes energy to do work, and therefore it takes energy to suck up energy, and where's the gain in that? So I'm not saying you can't do it. I'm just saying that at the present time, we know of no way to simply contain a forest fire. Sorry about that.